What can we call a living being? The question sounds trivial, but the definition of living beings is becoming more complex throughout the years on biology field. In the 70s, this question was raised by biologist Francisco Varela and Humberto Maturana under the concept of autopoiesis, the metabolism covering everything which is alive. The word autopoiesis describes the living being's capacity of producing their own components, keeping a self-controlled system working along the environment, dissipating a gradient of energy. When certain organic compounds are added to the water, they gather in micelles, which grow to the point of becoming unstable and splaying themselves. With experiments like this, Pierluigi Luisi showed us that it's possible to create synthetic autopoietic systems filled with distinct materials from natural biology. Nevertheless, they lack a primordial characteristic of living beings, the capacity of evolution. At the present time, living beings' evolution depends on DNA, which stores the genetic information needed on the production of proteins, responsible for producing all other sorts of cell components. As well, it can be copied during reproduction and reprogrammed for mutations. The DNA is a part of a mechanism capable of preserving the living being's organization amid the chaos of nature. When unexpected mutations occur on DNA results on new particularities which help the organisms to survive and reproduce. This information is stored and saved throughout generations, making evolution possible. But the occurrence of DNA itself is a dilemma, where its nucleotides are produced by enzymes, and the enzymes are produced by DNA. The Semiopoiesis theory suggests that the existence of another, much simpler, molecular information system can be the key of solving this matter. The answer might show up on organic molecules' natural capacity of storing information. Cryocenters, for instance, can assume two distinctive configurations that can both be used as an information-storing system. The major part of chemical reactions does not pass on any information to cryocenters, but the selective organocatalysts can do. As reported by Luisi, when certain organic compounds are added to the water, they gather in micelles, which grow up to the point of becoming unstable and splitting themselves. Micelles formed by selective organocatalysts can pass on information, which eases the surviving and reproduction of these systems throughout generations. The proposition suggests that the organocatalyst micelles were capable of evolution up to the formation of cells, which, eventually, would have transferred the information storing task to polymers such as RNA and DNA. Understanding the dynamic process between these systems is a one more step to understanding different possibilities of life that can be found in other planets. This knowledge can also help us create artificial living beings that could give us rise to programmable material capable of self-building and self-repairing.